Hello everyone. Today we are going to start with our first chapter of chemistry and our chapter name is chemical reactions and equations. So let us write it. It is chemical reaction and equation. So first of all, before starting this chapter, let us take the introduction of this chapter, that what this whole chapter is about of chemical reactions and equations. So before we come to that, we should know first of all that what is the meaning of reaction. Means how can we define a reaction? Means what is the basic definition of reaction? So now what happens is that in a reaction we say that the particular reactants. Now what are reactants? Reactants are those elements which take part in the reaction. They either combine means when the two reactants are there and they have joined together like this, or they can also dissociate. Now how can we say that when already some like this it was and finally it converted into like this? So they can either combine, which we can see over here, and they can either dissociate, which also we can see over here, to form the products. Now we should always remember that a chemical reaction always starts with reactants, and then so the chemical reaction will always start from the reactants and then it will be always converting into products. So this is the basic part of the chemical reaction which everyone should keep in mind. Now after this we have the identification, that how can we identify whether chemical reaction has taken place. So now we should note the next heading, that how to identify. What is the method of identification that a chemical reaction has taken place? Now this can be identified when any chemical change occurs. So any chemical change, when it occurs, you can easily identify that a chemical reaction has taken place. Now how to know this? So we will be seeing various things, like first of all, if I talk about, we see that there are some color changes. Means we can say that color changes can take place. We can also say that there might be some of the temperature changes. Means anything can happen. So we can have color change, we can have temperature change, we can also have some other things, like when we can have the evolution of a gas. We will see the example that where we can find that a gas has evolved. So this thing also can be seen, and we can also see that other than these we can have some sounds, like we can have pop sounds here. So pop sounds can also indicate that the chemical reaction has taken place. So we can say that we either color change can be there, temperature change can be there, evolution of gas can be there, or some pop sounds can be there. If these four things are happening, we can say that any reaction has taken place for sure. Now let us understand that how can these reactions take place, and let us understand them each one by one in detail. Now the first example that you can see is the burning of magnesium in air. Now this is the most relevant example. Now what is happening is that when we burn magnesium, whenever we try to burn the magnesium in air, now what happens, that let us see. So when we burn magnesium, so what happens finally is that it burns with a dazzling white flame. Now what is the meaning of this dazzling white flame? Let me explain you. So we have a dazzling white flame. Now let us see the meaning of, what is the meaning of this dazzling white flame. So basically what happens is that whenever we burn magnesium, okay, first of all, before that we should write the reaction, that how can this take place. Now you have already studied in a previous class that magnesium is represented by this symbol, that is Mg. Now it is burning in the presence of air, means we can write O2 because air contains oxygen. Now it forms a compound which is known as magnesium oxide, and what is happening, we are burning it. Means now this symbol which you can see here, this shows the symbol of a Bunsen burner. This is a type of a Bunsen burner. We use this burner in the labs to heat something. So it actually looks like this, it resembles like this, it is like this where the flames are coming out. So this whole apparatus, because it being the triangular, we can represent it like we can represent this whole apparatus also likewise this also in this way. So this is here how it has been shown. Now this magnesium plus oxygen burns to give magnesium oxide, and we also write here 2. Now why we are adding this 2? This means we are balancing the equation. This we are going to understand further on, but let us understand that what is happening in this reaction. In this reaction we have magnesium. Magnesium is combining with oxygen to form magnesium oxide. Now this MgO. Now what is this MgO known as? Let me write it over here only. This MgO is known as magnesium oxide. Now this Mg is known as magnesium oxide, which has been produced over here. So this is the basic reaction that has taken place. Now what happens is that, what is the process? Now we have to take the magnesium ribbon first of all, and we have to rub it with a sandpaper. Now what is a sandpaper? So first of all, the first step should be to rub it with a sandpaper. We have to take a magnesium ribbon. Now this magnesium is available in the form of ribbon. We have to rub that ribbon with a sandpaper. Now why we are rubbing this with a sandpaper is our question. So let us see the answer. It has very simple answer. What is the answer? Is that when we take magnesium, this magnesium ribbon was already present in the air. So when it was exposed to air, that time we had a layer of magnesium oxide already on this magnesium ribbon. Means if this is the magnesium ribbon which we have here, so here on the outer side of this hole we already had MgO layer, and inside we had the pure magnesium. Why this MgO layer? Because already we have outer attack of oxygen from everywhere. So to remove this magnesium layer, to remove this and to get a pure layer of magnesium only, if we require only a pure layer of magnesium, we require a sandpaper. So that sandpaper has been told to you here, that why do we require a sandpaper, or why we are rubbing this magnesium ribbon before burning it in the sandpaper. Now you have got this magnesium ribbon. This is a pure magnesium ribbon. Now you can burn this magnesium ribbon in the presence of already existing oxygen in the atmosphere. You can burn this and it will be forming the magnesium oxide. Here also you have to write 2, and here also we will write 2. Now why we have added here also 2 and why we have added here also 2, that is our major question that we are going to discuss when we will discuss the later parts of this chapter. Two things are very clear from this experiment. One is let us start our second reaction, that is the reaction of lead nitrate and potassium iodide. Now before we start this reaction, we should at least know the formula of lead nitrate and we should know the formula of potassium iodide. Now lead nitrate is nothing but PbNO3. Now this is the formula of lead nitrate. This Pb which can be seen over here, this stands for lead, and NO3 which can be seen over here stands for nitrate. Similarly this K stands for potassium and I stands for iodide. So these are the two things, that PbNO3 is lead nitrate and Ki is potassium iodide. Now we have to react these two compounds. Now first of all let us understand the mechanism of this reaction. Now such type of reactions where we have to learn about lead nitrate and potassium nitrate, these are known as displacement reactions, or if we say that more specifically, what are these known as? These are known as double displacement. These are known as double displacement reactions. Now how do these double displacement reactions take place? Now you should know that, suppose we have one compound which is like this, AB. AB is our compound which contains two elements. A is one element and B is one element. Similarly we have another compound which is like CD. This is again one compound where we have C as one element and D as the another element. Now what happens is that when we try to react this, and it happens such that this A is shifted with this C, means A and C join together and the remaining one, B, gets added to D. If such type of reaction takes place, or we can have another result also. Suppose we have AB N. We have AB here and then we have CD here. Another result that can take place is we get AD, means this A combines with this D and this remaining C will combine with this B. This can also take place. So the both of the type of reactions can take place, means we have both result. This can also take place and this can also take place. These reactions are known as double displacement reaction. Why these are known as double displacement reaction? Because here two displacements are taking place. A is taking C and B is taking D. So A is taking C is one displacement reaction, but B is also taking D is another displacement reaction. We have also just displacement reactions also. Now if you want to know that what are the displacement reactions, means only displacement reactions, here we have this type, like we have AB and this combines with C, so it will give AC and this B remains separated. Now here only single compound B has been displaced, so this will be known as single displacement reaction or only the displacement reaction. Now in our case, what do we have? In our case we have the reaction as PbNO3 plus Ki. Now you can see that there are two things, Pb is there and NO3 is also there, and here we have K as well as I. The two things are already there. Now see what will happen. This Pb, it is going to combine with this I, this NO3 and K, these will be combining with each other. Now here one displacement and two displacement, so that's why this is known as a double displacement reaction. Now finally what result can we have? So let us see. As I already told you, we had Pb with I, so we will form Pbi. Now what will this be known as? We'll write it, and we have KNO3. The two things are separately formed. Now this Pbi, which has been formed over here, is known as lead iodide. Very simple. And this KNO3 is known as potassium nitrate. Now this is very important according to examination point of view. They might ask you the mechanism also. They might ask you that what are the products formed. So we have lead iodide and we have the potassium nitrate. Now you see, my dear, one thing very carefully, that this lead iodide formed is of white color. So now what happens when you take this whole reaction in a test tube? So what happens is, then when PbNO3 is taken in already test tube, we had one test tube here. In this test tube we already had, inside this we have had PbNO3, and now what we did was that we added Ki from above. Now what happened was that when these two reacted and when displacement took place, the whole of this inside turned to white color. Now they might ask you the question that why is it has been formed white color. So we can say that due to the formation of Pbi, we have the white color over here. So this is one reaction, one mechanism which has taken place over here, that is a double displacement reaction.